edges, components, and holes using this summary, what we call persistent diagram. This is a persistent diagram. So every bar corresponds to a component. And here, let me proceed with the. So at parameter epsilon naught, 4 components exist. This is 4. Then we continue until epsilon 3. So 4 components. That's why you get 1, 2, 3, 4 lines. 4 lines, sorry. 1, 2, 3, 4 lines, right? The black lines, right? So this is basically a bookkeeping way of looking at the simplicial complexes appearing and disappearing. So at epsilon 3, a hole appears because here the edges are joining up the points, but nothing in the middle. So you have a hole here. So the hole persists from epsilon 3 until epsilon 4. Epsilon 4, the balls are getting bigger, so the hole disappears at that point, right? So that's what I said just now. So eventually everything joins up together. And from this summary, we form another summary, what we call a landscape, which is this picture. So from this picture, we transform it into this picture, which is pretty standard. And this picture will give you another picture, which is what we call persistent landscape of the data. These are pretty standard way of working when you do persistent homology, all right? So there's nothing new here. So now, what is critical slowing down? Critical slowing down, has been applied in many areas. It's a way of looking at certain indicators and seeing what happens when the system approaches critical point, tipping point. Another familiar word for it is tipping point. So, for example, in climate research, right, they have shown that critical slowing down occurs, and these can be used to detect sudden shift to a different regime in climate research. The references as such. I'll give you the full reference right at the end of this talk. So, general indicators for slowing down are using what we call variance and power spectrum time series of the data. All right. So theory of critical slowing down explain when the tipping point is approached. So we can use this theory to detect when tipping point is approached. Right. So like I said, the 2 most common indicators to find early warning are variance and power spectrum, right? So let me go quickly. And the next thing is to use quantile estimation, which is standard tool in extreme value statistics, right? To detect the days of when the change in the behavior of the variance and power spectrum occurs, right? So to detect rare events, in other words. So let me go quickly. So here is the evaluation of theoretical features during the 3 days of, I'm just choosing 2004, 1 day before flood, 11th of December, first day of flood, and 20th of December, 10th day of flood. So what we get is the point cloud data is 1 day before, on the day, and 10 days before. So you see the point cloud data changes visually. That is, we can see their visual change from the point cloud data on the first, on the 1 day before, on the day, and 10 days after. So these changes can be detected better using persistent homology, whereby we can detect the what do you call it, change in topological features of the first of the day before, on the day, and 10 days after. So you see the difference in the persistent diagram of the homology, persistent homology. And then from here is a standard way, a standard tool to change it to persistent landscape. Persistent diagram, we can do statistics. We can look at the mean and things like that. All right. Okay. So after that, which I didn't mention at all earlier because it's a bit technical. So from the persistent landscape, we get another time series, what we call L1 norm. L1 norm. This is the final time series that we're working on. This is the final time series that we're working on, and it is this time series that we apply critical slowing down theory to. So the critical CSD is applied to this time series, L1 norm time series. So let me go through CSD quickly. So if we look at the variance and spectral density of the L1 norms, so you will see that at the event of the flood, you will see very distinctive behavior of variance and power spectrum. This is showing that something's happening. So this is what we detect. This is what we use to detect flood. All right. And next thing is to use quantile estimation on the data set. And for example, let me tell you how to read this table. So if we use 12% quantile estimation, we get 10 early morning, 2 days late, we get 4 false alarm. So the weight is just a technical thing to give a preference to these signals. All right. For also, if you use 16%, if you choose 16% quantile estimation, you get 11 early warning, you get 1 late, and you get false. All right. So eventually, what we use is we found that the biggest weight at quantile 12 is at 12%, with result 10 early warning signals, 2 detection, and 4 false alarm. So we do get false alarm. We do get false alarm. But what I'm saying is we have a better result on early warning than false alarm using persistent homology. So this is our finding and comparative result using the first column. The first column is the flood event, the dates of the flood event. The second column is our early warning system using persistent homology, and the third column is early warning system without homology. Okay, you will see that. Let me summarize in a minute. So we do get early warning system on before the actual event and things like that, right? So to summarize, a flood early warning system through persistent homology provides advantage by reducing the number of false alarm to 4 compared to 6. So when we use persistent homology, we reduce the false alarm from 6 to 4. So the number of false alarm has been reduced using persistent homology as compared to without persistent homology. All right. So the conclusion is we have successfully applied persistent homology to this field of hydrology, especially the data of Kelantan River. Of course, we would like to test this theory with another data set. If you have any data set that you want to share with us, we will be happy to analyze it. And then the signal of as though
recording in progress
as the processing step for flus has an advantage in terms of reducing the number of false alarm. So these are the references. I can leave you the slide to the organizers if you're interested. So with that, I thank you very much, and I welcome any question from you. Thank you so much.
Thank you very much, Professor Salmi. It's a very interesting topic about the applied mathematics. I think this is one of example of from many examples from the applied mathematics, and very good to learn also, because it's like kind of the for mathematician is kind of down to the earth. It means very applicable. I think very applicable if this article or this research can be developed furthermore. Okay, thank you very much, Professor Salmi. And
thank you.
Okay, ladies and gentlemen, before we are going to the next presenter, I just remind all of you to write your question in the chat room. Please mention the name of the professor that you want to ask, and also mention your name. Okay, thank you very much. And we are going to the second invited speaker. He is Professor Wen Hao Chen. Ni hao, Professor.
Yeah, okay.
He's my professor. Professor Cheng is the professor in Applied Mathematics Department in Tunghai University, Taiwan. He has a bachelor degree in National Tsinghua University, Taiwan, and finished his PhD degree in National Chungcheong University, Taiwan. His expertise are in the differential geometry and its application to matrix information geometry and the relationship between curvature and topology in Riemann manifolds. He has been vaccinated some research also in the undergrad mathematics education. Now he has research about mathematics and geometry education. Without further ado, I would like to welcome the second presenter, Professor Chen, to deliver his presentation about on the geometry of matrix spaces. Okay, Professor Chen, this time and screen is yours.
Okay, thank you, Jafar. Thank you, everybody. Hello, good morning, ladies and gentlemen. I am Wen Hao Chen from Taiwan. Okay, today I just share the. Yeah, okay, so can you see my PPT?
Yes, bro. It is clear.
Okay, thank you. Okay, I just, yeah, okay. Okay, yes, and I just share the full screen. Yeah, okay, I see you can see the full screen. Okay. Yeah. Okay, I come from Taiwan, and today I will present I think somewhat more abstract about mathematics, and it's an interesting topic, connect geometry and the matrix space. Okay, before my presentation, I just want to thank you this conference and the committee for invitation to me to have this opportunity to present my my work. And I remember 2 years ago, it's ICSMTR is a very warm and very unforgettable experience for me to go to the conference. And everybody know because of the situation, the COVID-19. So now we can only online, but I really hope maybe next year or next year, I have the opportunity to go to Makassar to join the conference and maybe with my old friend and have a conference in Makassar. Okay, now I just for today I will talk about the geometry and the matrix space. First, I think I can show we know the Gauss, the mathematician Gauss use the calculus to study geometry to measure the world we live in and answer the long-standing question about whether Euclidean parallel portal is applicable to general curve space, which lays a foundation of modern differential geometry. And we know his student Riemann generalized Gauss theory and then developed Riemann geometry and become an important theoretical basis in Einstein's general theory of relativity. So in this talk, we first introduce an important concept in Riemannian geometry, such as Riemannian manifold, Riemannian matrix, geodesics, sectional curvature. Yeah. Okay, and On the other hand, it is well known that a study of geometry means on positive definite metrics. We use a P matrix to represent a positive definite metric. It's an important topic to many disciplines of science, such as apparatus theory, physics, engineering, and statistics. Today we just focus on the theory, mathematical theory, or not on the application. So we know the arithmetic mean is we can compute the arithmetic mean of geometry and the harmonic mean, just like the numbers. And interestingly, the positive definite metric space itself can be equipped with a Riemannian manifold structure. This means we can build a metric space just like a geometry, just like a space. So this work is first from proof and one know with first define the geometric mean of two positive definite metrics as follows, just like this formula. It's somewhat complicated, but at the data of this talk, we will explain this has the geometric meaning. This definition happens to be the midpoint of the geodesic between 2 points in positive metric space. This talk will mention some properties about geometric mean of we call PD matrix and introduce some new variables. Okay, first we just very brief introduce the differentiable manifold. A differentiable manifold viewed as a space which is locally diffeomorphic to Euclidean space, or a locally diffeomorphic to an open set in Euclidean space. So the precisely definition is just like this. M is a differential manifold. If there is an atlas just like this, and the diffeomorphic here is a diffeomorphic. Diffeomorphic means we have a mapping is a 1-to-1 onto differentiable, and the inverse is also differentiable. So we can have an example about the diffeomorphism of the open intervals -1 to 1 and minus infinity to infinity are diffeomorphic. Because from the topology or just a diffeomorphic point of view, they are we can just look they are the same. So for example, we can consider the function just like this. And what kind do we have an example about manifold, differentiable manifold? We can use this very common example. An unit sphere in the space is a differentiable manifold. For example, we can just make them locally diffeomorphic to Euclidean space. Just the map can just like this. Okay, and we use the implicit function theory in analysis or in calculus for high dimension. We can know the following matrix space are differentiable manifold. This is very interesting because they are all matrix space, just like a general linear group. It's just like a matrix, and this matrix is invertible, yeah. Or a special linear group, if the determinant is equal to 1, and the orthogonal group, and the special orthogonal group. And this is we will focus on this. All the PD matrix. So all the matrices are not only differentiable manifold, but also group. So such space are called Lie groups. Yeah, this use the mathematician name Lie group. Lie groups are very important in physics and engineering applications. So, for example, the unit circle is the Lie group. So Lie groups not only the group is a manifold, has a group structure. Okay, and then we introduce Riemannian matrix and the Riemannian manifold. So Riemannian matrix we can just build as an generalize the idea of inner product in Euclidean space, and then the distance function on a manifold can be defined by this. So if PQ is 2 points in the manifold, and we can have a curve connecting P and Q, then the distance from PQ, we can just use this, the increment of the length of the curve from connect P and Q. So a Riemannian manifold is a differentiable manifold equipped with a Riemannian matrix. Or we can also view it as a Riemannian manifold is a differential manifold, and we can define a so-called Riemannian matrix, or we can compute the distance of 2 points on the manifold. Okay, so we can have some example. If we define different metric, we can have a different straight line on the space. For this is a very famous metric, or we can say this kind of metric space is so-called hyperbolic space. So if we use this as a metric on the unit disk, then the straight line is just like this, or this the triangle in the space, or this it's a four side. So this is a very famous picture. It's a mean circle limit 4 by Fisher painter. So okay. At the identity matrix, okay. So for general linear group, it's just like this, and the spatial linear group, orthogonal group, and the spatial orthogonal group. So what kind of metric, or how we define the inner product in this space? We can use a very we can understand it's just like this. If two tangent vector, we define the inner product just the trace, is a trace, the transpose of x and y, the product of transpose of x and y is the Riemannian matrix on those vectors. Okay. So another important idea in Riemannian geometry is the so-called geodesic. Geodesic view geodesic just like this. A curve is on a Riemannian manifold is a geodesic if it satisfies so-called geodesic equation, and we can understand this idea just like a straight line in the plane or in the space. So we can use the first variation formula. This is the property that the shortest path joining 2 points is a geodesic. So it's just like this. We can say this is just energy function. The energy function we want to find the critical point. Critical point just means the shortest energy or shortest length of the distance. So it's a geodesic. So or we can briefly define what curvature. Curvature means we want to describe how a curve or a surface curve. The curvature of a surface at a point can be viewed as the rate of change of the normal vector at the point. So just like this. So we can use this to define the so-called sectional curvature. It's the plane. This
Hello, Professor. Hello, Professor Chen. Maybe there are some connection problem. Okay. Be white. Okay.
Okay,
Okay, bro.
sorry. Yeah,
Okay,
yeah,
no,
yeah. But I think maybe the internet
the
is,
connection maybe, yes.
yeah, yeah, yeah. Okay. So now you can see my screen. Okay. Okay. So continue. Okay. The file is okay. You can see the screen. Okay. Yeah, it's okay. Okay, yeah, we just continue. Okay, and for the metric analysis, we just that this all and by a real metric, and we can define the inner product. Let's see. Okay, we can in the inner product it's just like X transpose and the product Y, and the inner product we can just use this. And define this symmetry matrix. So we have the following theory. Okay, and then that will be a sequence of metrics, and the following conditions are equivalent. So this is somewhat approximation from AK to K in the two norms, just like this. Okay, and we brief introduce a positive definite matrix. So if A is a symmetric matrix, the so-called positive definition, a positive semi-definition is just like this. And a positive definite, if A is positive semi-definite and invertible. Yeah. So we can just use this idea to show B minus A, two matrix B minus A is positive. Yeah, we can use this idea to define A less than or equal to B, or A less than B. So N by N symmetry matrix is a positive definite if just like a list. This we can have the properties just like every leading principal submatrix of A has a positive determinant, or eigenvalue are positive, or pivots of A are positive, or A can be represented by this kind of matrix. Okay, so example of a positive definite matrix, I think we can just show you, for example, all ellipse with symmetry at the origin. Yes, then we can find a positive definite matrix, or just like this, Yeah, this equation is represent as ellipse. We can just change by this form, different form. Yeah, use this. And we have a very important idea is not that if there are now if we have two positive definite metrics, will not ensure the product of these two matrices still positive. So just like this, if A is a list matrix and the B is this matrix, we can know these two matrices are both positive definite, but the product B is not positive definite. So the reason is that AB is not symmetric. Okay, so another property is now that there are examples that A, B are positive definite, but A bigger than or equal to B, but A square is smaller than and equal to B, just like this. So we have the following series. If A is a semi-positive, then there exists a unique matrix X such that this is just like a square root of the matrix. Okay. So we have some properties of positive definite matrix. So if A, B are positive definite and A less than or equal to B, then B in the inverse of B less than or equal to A, inverse of A. So you can just prove just like this. And if A, B are both a positive definite matrix with A bigger than or equal to B, then the square root matrix of A and bigger than or equal to square root of B. So the proof is just like this. Okay, and why this is important? Because it have a relationship with the probability. So probability distribution and the statistics models is we just let X be a discrete subset of Rn. So the probability distribution is the function which satisfies this formula. So if let S be a family of probability distribution on X on the space, suppose each element of S that is a probability distribution may be parameterized using a real value variable, just like this. So we can set up a so-called n-dimensional statistical model. So if there is a differentiable function on the statistical model, then that is open in Rn. So then S can be called a statistical manifold. So we can just view the statistical model as a statistical manifold, just like we use a differentiable manifold idea to statistics. So the example just like this, so we can use normal distribution or multivariate normal distribution. So we can just use the distribution function satisfies this formula. Okay, so now the statistics model is a differential manifold. So as we mentioned before, we want to equip a so-called Riemannian matrix on this statistics model. So let S be a statistics model, and we have the expectation functions. Then the information matrix is the so-called Fission information matrix. Is defined like this. So by computation, this matrix, this matrix is a positive semi-definite matrix. So we can use this to equip a Riemannian matrix on the manifold. The manifold is a statistics model. So this matrix is called a Fission Metric or information matrix. Okay, so the multiplicator normal distribution with zero expectation are given by this formula. So the tangent space is that the proof can be shown is a symmetry matrix. So the information that we can have is a positive definite matrix. So the tangent space FA satisfy that, this just like this. Therefore, if Pn is equipped with an information matrix, then this positive definite matrix with this positive definite matrix space with this Riemannian manifold. So it can be shown that this Riemannian manifold is the so-called complete Riemannian manifold. This means complete Riemannian manifold with non-positive curvature. Non-positive curvature means that every 2 points in the space have one and only one geodesic connect these 2 points. This means there is exactly one geodesic join any 2 points of positive matrix. So that A and B be any 2 elements of positive matrix, then there exists a unique geodesic join A and B. This geodesic has a representation like this. This means we consider the space this space is all positive definite matrix, and we equip inner product, and we equip the inner product. We can just show that this Riemannian manifold is non-positive or non-positive curvature. So every 2 points now is means every 2 positive matrices. We can join them, abstract line, abstract curve, and this is the one and the only one. So the curve in the formula is just like this. So we only can see the matrix A is the identity matrix. Then this curve is just like this, the transpose of B. So we can use a geodesic formula to show that, yeah, it's a geodesic. So by the geodesic equation, since is independent on T, so gamma T to BT is connected to identity matrix T. So in 1975, the Polish mathematician and the physics Booth and define the geometric mean of 2 positive definite matrices just like this. Use this formula. Yeah, this formula. So for positive definite matrix, we can define the square root of the matrix. So this is meaningful. So from the viewpoint of geometry, the geometry mean of A and B in P equipped with the information matrix is just the midpoint of the geodesic joint A and B. So this interesting and the related important results are contributed by Indian mathematician Bhatia and the Hungarian mathematician Pet from 2005. So we can have some theories about this definition and this property. So we just ignore this. Yeah. Okay. So they have some properties just like this. Yeah. If the geometric mean just like this. So we have we can just compare this property with positive numbers. So if AV are commutative, then we can have this property. For positive number, we know this one and this one. So we have some property. All this property can be proved, and we know the less one, this arithmetic mean, and this geometric mean. So for the proof, we just show here. And this proof is not so difficult, but it's very interesting. So for 3 positive definite matrix, properties about it. Okay, we just ignore this. Okay. So the lesser one is a harmonic geometric arithmetic mean inequalities, just like this. Now it's for 3 matrix, 3 positive definite matrix. We know for positive numbers, for numbers is okay. For numbers is okay, but for matrix it's not so easy. So we can define this. So this means ALM. Okay, so for our contribution is we just define if they have a sequence of positive definite matrix, we define AN, BN, and Cn. So we just have find the limit of all this sequence of matrix that have this limit.
I'm sorry, Professor, you have 5 minutes.
Okay. Yeah. Okay, we just that's one. Okay. So in case of positive numbers, we know if we now have A, B, C, positive number, and define the sequence AN, BN, and Cn. So we have this one. So now if we change positive number to positive definite matrix, yeah, we have just like this. So we can define this limit. So we just show this limit and the ALM geometry mean is equal. So now we have the question as how to define exactly and compute the geometric mean of 3 positive definite metrics. And the other question is how to apply the geometric point of view to geometric mean of more than 4 positive definite metrics. I want to show it's very different from positive numbers to positive definite metric, but they have some property, the similar properties. So we want to show the properties in positive numbers to positive metrics, but there is some we have meet these 2 questions. I think these 2 questions, if we can solve these 2 questions, we can apply this to another discipline. Yeah. Okay. So finally, I just introduce myself. Different geometry and its application to metric information geometry. So if you are interested in this, I have a review paper for this slide. And I have an ongoing research project with Java and for the economics. So if you are interested in this field, we welcome you join our project. Okay. So thank you for your attention. Thank you.
Thank you very much, Professor, for the interesting pure mathematics topic. Yeah. And ladies and gentlemen, okay, please, if you have a question, please write your question in the chat room. Okay, thank you very much. Also, now we are going to the next invited speaker, Ibu Dr. Mesuri Patahuddin.
Assalamualaikum.
Waalaikumsalam, Bu. Ya, semoga masih ingat Pak Lugis, Bu ya. Dengar ramu apa Bu Abas Ugi ya. She is the UNM alumni, okay, of course from Mathematics Education Department. Actually, she was a legend in my time. Actually, if some students said that about Ibu Mesuri, so she's a legend in this in the mathematics department in the student. Okay, and Ibu Mesuri has a master degree from Universitas Negeri Surabaya, and she finished her PhD degree in University of Queensland, Australia. Now she has a very interesting project about early learning STEM Australia, using active learning as a tool for developing effective student-centered personalized learning experiences. Okay, and this morning, Ibu Dr. Mesuri will share about examining gender differences in textbook using amongst the teachers, evidence from Indonesia. And okay, Ibu Dr. Mesuri, okay, this time and screen yours.
Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Oh, good afternoon from Canberra.
Oh.
Thank you so much, Pak Jafruddin, for the very kind introduction. Thanks to all the organizing committee of this conference who have been working very hard to put this together. I hope everyone has enjoyed the conference since yesterday. Also, I would like to thank you to all the key stakeholders of Makassar State University, including the Dean, Kakanda Dr. Suwardianas, and Vice Dean Kakanda Dr. Widasa. And thank you to my beloved educators, Ayahanda Professor Arif Tiro, and my very good friends, Ibu Asri, Pak Sukarna, and Professor Muhammad Salmi and Professor Chen. Thank you for the very sophisticated presentation. I've enjoyed your presentation. It showed me there are so many things to learn, and there are so many things that I don't know. Okay, and Professor Salmi and Professor Chen, my apologies. I am going to use 2 languages here in my presentation, but all my slides are in English. All right. Okay, so let me share my screen. Share screen. Yep. So the theme of this conference is optimizing data science to reach society 5.0 through high quality research. To be honest, I don't know much about Industry 5.0 yet. My colleague, Dr. Ajay Rangpur, and myself just have a chapter book published this year with the title, The Fourth Industrial Revolution, Implication for School Mathematics. So Makassar State University is very ahead. They already talk about Industry 5.0. So in this chapter about Industry 4.0, we discussed about how the school mathematics curriculum should be reshaped to align it to the demand of Industry 4.0. In this chapter, we talk about the characteristic of Industry 4. Yeah, we talk about cloud technologies, robotic, artificial intelligence, augmented reality, virtual reality, 3D printing, computational thinking. And it may be the case that we haven't harnessed the technology from Industry 4.0, and now we are preparing Industry 5.0. Okay, yang pasti teman-teman, menurut saya tema ini itu dealing with big data. Yeah, this is dealing with big data, and therefore I thought research in social media often deals with big data, and Indonesia certainly generate so much data on social media, especially during COVID-19. So I decided to present my research in social media in this conference because I am very sure that we can develop high quality research in this area. And I think we really need the expertise from statisticians to help us to understand the phenomena of social media. Yeah, there are so many things that we need to unpack. So the title of my presentation today is examining gender differences in Facebook usage among mathematics teachers. And this is evidence from Indonesia. So this is the outline of my presentation. I am going to explain the background to illustrate why am I doing what I am doing. And then I will take you through to the method and the findings as well as the lessons gained from this study. Okay, I have to manage my brain to speak in 2 languages. Jadi teman-teman, ada 2 kata kunci yang saya gunakan dalam presentasi ini. Oke, yaitu Facebook dan gender, jenis kelamin. Mengapa sih saya peduli masalah ini? Okay, so before I continue, let me ask every audience, how many hours do you use Facebook every week? Can you type your answer in the chat box? So I have some ideas about yours. So berapa lama kira-kira, berapa jam kira-kira teman-teman itu mengakses Facebook setiap minggu? Okay? Coba silahkan diketik ya. Oh, ada yang 12 jam, Pak Sukarna. Okay, 7 jam. Thank you. 5 hours, thank you. Okay, jarang-jarang ya. 24 hours, wow. All right. Thank you for your participation. So, why Facebook? Kenapa Bu Siti meneliti tentang Facebook? Facebook has been heavily used by people, including teachers in Indonesia. And the chat box here told me that justify my statement, my claim. So, according to the latest data that I've got, in 2020, Indonesia had 130 million Facebook users who actively access their account monthly. Okay, 130 millions. This put Indonesia into the top 3 countries of Facebook users. And I have been using Facebook by myself, particularly to promote informal learning. And actually, Facebook is under a spotlight as a tool for PD. Jadi Facebook ini semakin banyak diteliti teman-teman, karena dilihat bisa memungkinkan menggunakan Facebook untuk pengembangan guru. Oke, ini dua paper yang kami sudah publish bersama teman. Jadi papernya ini di tahun 2019 dan tahun 2020. Our study indicate that potential of Facebook for professional learning. However, in these 2 papers, I haven't talked about gender. Okay, the first article actually suggests that Facebook could be utilized as a medium to enhance disciplinary and pedagogical knowledge of teachers and educators. And then also we found that teachers mereka itu punya Facebook favorit di dalam bidang pendidikan. Teman-teman, saya bisa kirimkan paper ini jika ada yang berminat di dalam meneliti tentang Facebook. Nah, pertanyaannya, why am I interested in gender differences? Let me speak bahasa here, okay? Jadi mungkin ada yang surprise atau tidak surprise kalau saya itu sebenarnya sangat tidak peduli or ignorant tentang gender differences for many years. Saya tuh paling tidak suka, tidak peduli dengan pembicaraan tentang gender differences. Kenapa? Karena menurut saya itu adalah suatu hal yang normal. Karena sejak kecil saya sudah dididik secara berbeda. Jadi biasa ya, sejak kecil kita sudah ada perbedaan, bahwa misalnya perempuan tugasnya memasak, mengasuh anak, laki-laki itu cari nafkah, kemudian juga kita sering mendengar laki-laki perempuan jadi kasur, dapur, sumur begitu ya. Even my mom didn't finish elementary school, tidak selesai sekolahnya because the family prioritized male or brothers to do school. And then I became aware of this issue after I led a 4-year educational project in disadvantaged community in NTB. Saya jadi sadar kalau ini sebenarnya sesuatu yang perlu dikaji tentang perbedaan gender. Itu karena setiap tahun di dalam laporan proyek itu ada pertanyaan yang selalu saya harus jawab. Apakah proyek kami itu memberi kontribusi terhadap penanganan gap antar gender? Itu membuat saya berpikir, why is it important? So now, let me take you to the hard data. Saya tunjukkan data keras ya, hard data. So, secara internasional maupun nasional maupun regional itu disepakati bahwa setiap anak punya hak untuk menikmati pendidikan yang berkualitas, pengajaran yang berkualitas, dan kuncinya itu adalah guru. Nah, guru ini laki-laki dan perempuan. Nah, sekarang coba lihat datanya ya. So SD for elementary school 71% guru perempuan. Okay, junior high school 73% guru perempuan. High school, senior high school 61% guru perempuan. What does it tell us? Artinya apa? If we empower women, if we provide equal opportunities, so women has also lots of opportunities to be a very good teacher, that will have significant impact on education. Ini yang menjadi motivasinya Bu Maesuri untuk sekarang meneliti tentang perbedaan gender, gitu ya. Memang kita berbeda, tetapi itu tadi ya. Nah, but sadly, sedihnya ya, female teachers, guru-guru perempuan itu sering menghadapi peluang yang lebih kecil di dalam pengembangan dirinya. Gender inequality itu sangat jelas. Sebagai contohnya, kalau kita lihat dari sisi pangkat atau dari sisi posisi kepala sekolah, itu kurang dari 30% kepala sekolah perempuan. Atau kalau sudah pergi ke sekolah madrasah, itu mungkin kurang dari 15% untuk yang menduduki posisi kepala sekolah. What does it mean? Karena memang peluang mereka itu lebih sedikit untuk pengembangan dirinya. Bisa jadi juga belief, bisa jadi juga karena cultural aspect. Tetapi yang pasti, kalau guru perempuan tidak mendapatkan peluang pengembangan diri yang maksimal, maka bisa berdampak pada kualitas pembelajaran anak. Mari lihat literatur, look at the literature. Seperti apa perbedaan gender tentang penggunaan Facebook. Differences in user behaviors between female and on Facebook has been extensively studied. Okay, so misalnya saja perempuan itu dikenal lebih sosial gitu dibandingkan laki-laki. Perempuan itu lebih banyak waktu di Facebook berdasarkan studi-studi yang saya kumpulkan ya. Mereka perempuan lebih banyak postingannya. Kemudian lebih banyak perempuan punya lebih banyak teman daripada laki-laki. Tetapi ada juga yang suggest bahwa tidak ada perbedaan antara penggunaan Facebook perempuan dengan laki-laki di dalam hal jenis postingan. Misalnya dua-duanya ya sama-sama banyak memposting fotografi, foto maksud saya. Nah, yang pasti juga dikatakan bahwa perempuan dan laki-laki suka memposting foto, tetapi bagi yang laki-laki dia lebih suka posting video, yang perempuan posting link. Nah, sebenarnya what we know from the literature, ini penting, beberapa poin ya, bahwa studi-studi ini pada umumnya dilaksanakan di negara maju. Ya, Indonesia itu rankingnya tinggi sekali dalam hal penggunaan Facebook. Tapi studi Facebook itu masih terbatas teman-teman ya. Ini khususnya di statistik nih. Kita juga banyak sekali data kan di sosial media. Ternyata di Indonesia itu terbatas. Kemudian research participants dari studi-studi yang ada itu pada umumnya general users atau mahasiswa. Belum banyak yang tentang guru. Nah, lalu ada beberapa studi tentang Facebook sebagai medium komunikasi antara guru dan laki-laki, antara guru dan siswa, dan tidak ada perbedaan tentang interaksi laki-laki, guru laki-laki dan guru perempuan. Nah, itu. Nah, tetapi yang pasti limitation dari studi ini adalah bahwa studi-studi yang ada ini belum banyak mengeksplor tentang penggunaan Facebook untuk professional development dari gender perspektif. Nah, gap ini yang sedang saya usahakan address I am trying to address this gap. For this purpose, I conducted a two-phase study. Jadi saya melakukan dua fase dalam studi ini. Pertama, saya melakukan studi survei, ya. Surveinya sebenarnya dijawab oleh sekitar 1.000 partisipan, tetapi untuk presentasi ini saya fokus kepada 444 guru dari 33 provinsi di Indonesia. Fase kedua itu adalah mengeksplorasi, it was a case study, yang partisipannya sebanyak 177 guru SMP dari lebih 100 sekolah di 10 kabupaten di NTB. Nah, pada fase pertama, we investigated the Facebook socio-demographic user differences between female and male mathematics teachers. Jadi intinya kami menginvestigasi itu di mana sih mereka mengakses Facebook, berapa lama mengaksesnya, berapa banyak teman yang mereka miliki, berapa banyak grup yang mereka ikuti, Facebook grup favorit yang di bidang education itu apa, alasannya mengapa memfavoritkan Facebook itu, dan apa yang mereka tidak suka, kita explore itu. Nah, pada fase 2 dari salah satu Facebook favorit yang ditunjukkan oleh fase 1 itu kami selidiki, kami jadikan dia sebagai case study dengan menggunakan virtual ethnographic, ya. Jadi saya bagian dari Facebook tersebut. Nah, dari situ kami melihat, jadi yang kami lihat adalah postingannya, postingan guru laki-laki, postingan guru perempuan, dari sisi banyaknya, dari sisi jenisnya, dan kami lihat kontennya secara lebih detail. We zoom in, okay? Nah, sekarang pada fase 2 misalnya, itu postingan yang kami ambil itu dari Mei 2016 hingga Juni 2018. Sebenarnya postingan di situ banyak banget, ya, tetapi yaitu lebih 1.000, jadi ada 1.354. Nah, tetapi untuk studi ini saya fokus pada postingan guru saja, yaitu sebanyak 713. Nah, analisis yang kami pakai itu adalah kuantitatif dan kualitatif tentunya. Kami menggunakan non-parametric analysis. Nah, kita perlu nih orang statistik untuk membantu di dalam menganalisis data yang begitu banyak, ya. Dan kami yang paling berat sebenarnya menganalisis kualitatif datanya ketika kami perlu mengcoding data-data yang ada, ya. Misalnya ini contohnya, ini apa alasan mereka memfavoritkan sebuah Facebook grup pendidikan. Nah, itu codingnya, ya. Dan kita melakukan open coding ceritanya. Nah, untuk data analisis fase yang kedua, karena dia khusus di satu Facebook group, so we generated the data from the Facebook group. Tapi waktu itu kita menggunakan Gritix, jadi download data Excel keluar. Nah, kemudian kita menyeleksi, kita ambil yang postingan yang dari guru. Kemudian di sini kita menggunakan, saya dibantu oleh asisten saya untuk menganalisis data kuantitatifnya ini. Apparently they use Mann-Whitney U-test and chi-square. Jadi ke arah non-parametrik. Lalu kami menggunakan kualitatif data analisis. Tentu reliability-nya harus dibangun melalui kualitatif data analisis ini. Ada teknik-tekniknya sendiri, itu saya jelaskan juga dalam paper. Nah, kemudian apa dong ininya, temuannya Bu Maisuri, ya? Nah, ini temuannya. Ternyata teman-teman itu tidak ada perbedaan yang signifikan antara guru laki-laki dan guru perempuan dalam hal tempat mengakses Facebook. pada umumnya dua-duanya itu pada umumnya mengaksesnya itu dari rumah, ya. Ini syukur ya tidak di sekolah. Kemudian no significant difference between the period male and female teachers have held their Facebook account and the size of Facebook networks. So I use the tick, the green tick, just to indicate to you that there is no differences. Tidak ada bedanya dalam hal lamanya mereka punya akun Facebook, ya, tidak ada bedanya yang signifikan secara statistik antara laki-laki dengan perempuan. Begitu juga dari sisi jumlah temannya. Begitu juga dari berapa banyak Facebook group yang mereka ikuti, okay? No significant differences in reasons behind dislike of Facebook group. Jadi kan mereka diminta apa yang kamu tidak suka kalau di Facebook group itu, mereka berikan. Dan setelah dikelompokkan, setelah di-coding dan dianalisis, kesimpulannya tidak ada perbedaan. Nah, sekarang mari kita lihat finding dari fase kedua. Saya ingatkan kembali, fase kedua adalah kita lihat Facebook group-nya kan. Kita lihat jumlah postingannya, jenis postingannya, kita lihat kontennya apa sebenarnya yang mereka posting. Kita khususnya melihat dari kacamata professional knowledge, termasuk salah satunya mathematics pedagogical knowledge. Nah, apa temuannya? Ini menarik, saya senang juga nih melihat temuan ini. So the tick say no difference, no significant differences statistically. The cross itu mengatakan ada perbedaan in the finding. Jadi pada fase 2 ini kan kita mau examining the engagement behaviors, ya, between the two genders. So, temuan pertama, tidak ada perbedaan yang signifikan antara banyaknya postingan laki-laki dan perempuan di Facebook favorit ini, Facebook group favorit ini. Tapi ternyata ada perbedaan dari sisi postingannya. Laki-laki lebih cenderung untuk memposting posting link ya, jadi ada link mereka posting. Tapi kalau perempuan itu memposting video. Saya akan tunjukkan contohnya. Guru perempuan itu cenderung untuk lebih sosial, lebih interpersonal dalam hal kontennya itu ya, lebih banyak kepada interpersonal content. Kemudian guru perempuan juga guru laki-laki itu cenderung memposting matematika, soal-soal matematika. Tetapi menariknya kalau perempuan, kalaupun berbicara tentang matematik, itu dalam konteks bagaimana mengajarkan matematika itu. Menarik kan ya? Nah, ini contoh saja di analisisnya ini ketika menggunakan chi-square test of homogeneity. Kemudian ternyata guru perempuan cenderung memposting video, sedang laki-laki itu link. Video itu kan lebih susah ya. Kalau link itu langsung aja diposting kan gampang. Nah, ini contohnya nih. Ini guru perempuan. Guru perempuan ini he videoed her school, her teaching, not her school, her teaching, and then he posted several critical events from the classroom, and she posted and she asked for responses. Nah, and this attracted 41 comments and 20 reactions. Banyak yang komentari. Nah, kalau ini contohnya dari sisi ada teori Sulman for mathematics educators, they really know about Sulman. Sulman is proposing about what professional knowledge of that teachers should possess. Jadi Sulman ini kan sangat terkenal dengan teorinya tentang pengetahuan seperti apa yang harus dimiliki oleh seorang guru untuk bisa menjadi guru yang efektif. Nah, itu adalah salah satu coding kami juga. Nah, ternyata perempuan ini professional knowledge itu lebih banyak diinisiasi oleh laki-laki, oke, yaitu sebesar 62,24%. Tetapi yang perempuan itu lebih kepada bagaimana mengajarkannya. Nah, ini contoh postingan dari guru laki-laki nih. Jadi mereka memposting soal-soal matematika, problem solving. Nah, tapi kalau female itu juga banyak menginformasikan tentang project. Jadi kan di daerah-daerah itu ada MGMP. Nah, itu perempuan lebih banyak ngurusin MGMP tuh. Jadi lebih banyak posting mengenai bagaimana organizing lokal professional development, pelatihan-pelatihan. Sedangkan laki-laki biasanya banyak memposting oh ya, informasi-informasi pelatihan nasional atau regional ya. Nah, jadi banyak.
5 minutes.
I think this is my last slide. Alright. So then, what can we learn from this one? What lessons can we gain? So what Bu Maisuri udah capek-capek gitu, udah tahunan meneliti tentang ini. Terus apa dong, kan begitu. Jawabannya juga masih terus saya cari ya teman-teman. Yang pasti literatur sudah mengindikasikan ke kita bahwa laki-laki dan perempuan itu menggunakan internet atau menggunakan teknologi secara berbeda. Nah, tetapi hal yang baru yang memang saya tawarkan di dalam studi ini, kita jadi tahu perbedaannya antara guru laki-laki dan guru perempuan dalam hal akses internet, dalam hal akses sosial media. Nah, sebenarnya yang memotivasi saya untuk meneliti ini karena ujung-ujungnya ya, Bu Maisuri itu ingin mencari jalan bagaimana caranya untuk menjadikan Facebook ini atau Facebook Group sebagai kendaraan untuk pengembangan guru. Nah, dengan melihat perbedaan-perbedaan itu, kita kan harus berpikir bagaimana, apakah saya harus membuat Facebook Group khusus untuk perempuan atau justru digabungkan, karena kalau digabungkan mereka saling melengkapi, yang laki-laki itu banyak memposting matematika, yang perempuan ini banyak memposting tentang bagaimana mengajarkan matematik, ataukah misalkan saya mau mengembangkan kemampuan guru laki-laki agar bisa mengajarkan secara lebih sosial atau memberi feedback yang lebih friendly. Nah, mungkin saya harus memancingnya dengan postingan yang berbeda. Saya akan memancing dengan postingan yang berbeda terhadap guru perempuan dengan sebagai upaya untuk memperkuat pengetahuan matematikanya. Jadi ini adalah area yang sangat menarik ya teman-teman. Saya kira teman-teman kalau mau meneliti lebih lanjut, ini salah satu bidang saya. Jadi kalau mau berkolaborasi, ini adalah salah satu peluang kolaborasi. There are many questions. I will read the question. Thank you so much for everyone. Hopefully this is useful. Thank you.
Thank you very much, Ibu Maisuri, for the very interesting, informative topic. Okay, ladies and gentlemen, now we come to the question and answer session. There will be some question. I think the operator will show the questions. Okay. Yeah. I think we can, because there are many questions in the chat room, I think we can read the questions. Okay, can you show bigger? Okay. For Professor Salmi, the first question is, what's the characteristic of the river or mountain, or maybe some tremor from earthquake that we can be applied about the model, and how about it's not flood but a landslide? Maybe Oh yeah, maybe you can answer directly, Professor Salmi.
Yes, I mean I've given a written answer, but the gist of the answer. Can you hear me? Okay, Professor.
It is clear, Professor.
So the gist of the answer is to get data from appropriate location.
Oh.
So if you want to look at flood, you look at the river, which when overflow will give flood situation to the particular area. So data from the river which normally overflows is used in our current research to detect signal before flood, on the day of the flood, after flood.
Okay.
Thank you.
Okay, thank you, Prof. And the second question is from Sahlan. Is it possible that the solution to this flood problem can be approached from the side of algebraic analysis, such as topology or analytical mathematical modeling using differential equations?
Yes, of course, differential equation and partial differential equation have been used a long time ago in studying flow, flux, and things like that. So what we are doing in this research is adding a new dimension to a new tool in flood research by using persistent homology. But persistent homology has its roots in topology and algebraic topology. So that answers the question, I think.
Okay, thank you very much, Professor. Yeah, I think this is a very good for you, the who give a question, and thank you very much, Professor Salmi. And we are going to another question for Professor Chen. We have 3 questions for Professor Chen. The first is, what kind of the surfaces that can be find the information matrix, and how about the sphere surface?
Okay, I think information matrix that can be find in different disciplines. Here today, I just talked about something about the structure. So information matrix, you just focus on the matrix. But in my talk, I just consider about the space of all positive definite matrices, and we can equip the geometric structure and then find the geometric mean. I think this is somewhat different. And you say, how about sphere surface? I think you know, today I just present an abstract geometry space. We cannot see the metric space just like our space. I mean, we cannot see the 2 point because the 2 point is just metric. So this is somewhat different. Okay.
Yeah. Okay, the next question from Rega. Rega asks about the she is a lecturer from Makassar and Statistics Major. Is our material related to the courses, especially statistical theory, or not? Please explain, sir.
Okay. Yes. Yes. Okay. In my presentation today, I think in statistics, I just we can connect the course content about a probability distribution, but I think I think they have some relationship with when we teach linear algebra. Because we can find metric theory or some product of metrics in this topic. So I can suggest if when we just teach linear algebra, we can let students to compare the numbers and the positive definite metrics. In my presentation today, I just focus on so-called geometry. Is that for students, maybe when they are in, I think, junior high school, maybe they can just compute geometric mean of positive numbers. But this is a new idea of a geometric mean of positive definite metrics. This is somewhat different, and I think it's very, very interesting because we can let students to compare kind of properties should be satisfied for two positive definite metrics. Yeah, I hope I can answer the
this is the answer for Lega. And next question from Sahlan Sejarah. Is it possible to obtain a geometric representation for the other species such as polynomial species or in general vector species?
Yeah, okay, thank you. I think we know, we can have the idea about the classification of space in mathematics. I think the first level is and we can add an operation of structure. Maybe we can from a topological view and representation of other space. If you want to know if the space has so-called differential manifold structure, we have to just find from the definition of differential manifold, so-called diffeomorphic to Euclidean space. Yeah, and if the space have a manifold structure, and then we just want to know if they can be equipped a so-called Riemannian metric, and then they may be become a geometric space as we know. So just other space, I think many space have the structure we can equip, or we can view the space as a different geometric representation. Just when at my talk, I just present, for example, metric space, just a general linear space. It means all the metrics with non-zero determinant, or there is the matrix of all the invertible matrix. It can be viewed as a geometric space. So I think so just like a general vector space, and this depends on how you make them the geometric structure, or in addition to equip with the metric. Yeah. Okay, thank you.
Okay, thank you very much, Professor. Yeah, Pak Salan, it's the answer. If you have any response, maybe you can type again in the chat room if we still have time. Okay, and the next question for Ibu Dr. Siti Maisuri from Pak Sukarna. Bagaimana siswa Australia terpengaruh oleh Facebook? How have Australian students been addicted to Facebook? How have teachers been guidance them? This is from Pak Sukarna. Please, Ibu Maisuri.
Thank you very much for a very good question from Pak Sukarna. Satu hal yang saya catat di Australia ini adalah kepedulian pihak Department of Education untuk mengantisipasi negative impacts of Facebook. Jadi orang tua maupun guru itu menjelaskan tentang sebenarnya dampak dari Facebook. Jadi kalau di Indonesia itu sangat umum ya kalau anak-anak punya Facebook. Kalau di sini itu tidak begitu umum. Jadi biasanya kalau mendengarkan orang tua, ya kan, mereka akan bertanya kepada anaknya untuk apa. Ini berdasarkan pengalaman saya. Dan mereka sejak kecil, saya ingat anak saya ketika SD itu sudah diingatkan jangan sampai memposting profilnya foto mereka sendiri, fotonya. Itu sangat riskan gitu ya. Nah, yang perlu saya jelaskan kepada teman-teman, area dari penelitian saya ini adalah orang dewasa ya. Jadi saya tidak banyak kepada Facebook anak-anak. Oke? Tetapi orang dewasa. Tetapi kalau kalau anak sekolah itu memang di sini saya ingat betul, misalnya polisi datang ke sekolah menjelaskan apa bahayanya, apa yang perlu dihindari, itu dilakukan. Mudah-mudahan jelas ya.
Ya, Bu, ya, jelas. Second.
Thank you, sangat jelas.
Terima kasih.
Kasih Pak Sukarna. The second question. Yeah. From Rega. I will ask about the how to deal pornography on Facebook and other applications that are currently real.
Nah, terima kasih. Jadi ini berkaitan betul tadi ya dengan masalah perlunya penjelasan tentang bagaimana menggunakan sosial media secara aman. Hal yang perlu diketahui oleh semua dan mungkin teman-teman kita sudah banyak yang tahu bahwa hati-hati sekali di dalam memilih atau melihat postingan. Karena katakanlah dengan saya ya Facebook, saya tidak mengalami masalah tentang itu. Karena memang saya tidak pernah ke arah sana. Jadi itu yang benar-benar benar-benar perlu dieksplor ya, perlu juga dididik masyarakat kita. Ini orang statistik nih yang punya tugas betapa bahayanya itu data yang di-capture oleh Facebook. Jadi kalau you pergi ke jalan setan akan dikasih terus ke jalan setan gitu. Kalau kepada yang baik-baik, yang sumber-sumber pendidikan, maka dia akan datang karena alat analitiknya itu akan mengarah ke sana, begitu. Jadi ini juga sebenarnya memotivasi saya untuk terjun ke bidang penelitian media sosial sebab sebenarnya banyak sekali bahayanya, tetapi potensinya juga besar, tergantung si penggunanya, iya nggak? Terima kasih.
Yeah, the next question is from Bapak Kasim Aidit dari UNM. Bagaimana cara mengambil data di Facebook? Apakah manual atau menggunakan software tertentu? How to take data from Facebook or manual or the certain software?
Excellent questions ya. Untuk studi yang saya presentasikan itu saya menggunakan analitik namanya Gritix. Waktu itu saya bayar $25 atau sekitar 250.000. Waktu itu belum ada kebijakan dari Facebook, masih belum bermasalah. Jadi Facebook menjual data kepada third party begitu ya. Tetapi jangan khawatir, yang utama di dalam melakukan penelitian Facebook itu kita harus mengikuti research ethic. Oke? Ada etika di dalam meneliti, termasuk di dalam penelitian Facebook. Nah, bisa saja ada kemungkinan data analitik itu tersedia juga, tapi tergantung dari orang yang menjadi subjek penelitian kita. Misalnya di dalam grup itu mereka setuju untuk diteliti. Nah, saya berikan satu contoh ya teman-teman. Mahasiswa bimbingan saya, mahasiswa S3, itu meneliti tentang bagaimana membantu guru untuk mengajar spatial reasoning di Maluku Utara. Rencananya trainingnya ini dilaksanakan face to face di Maluku Utara. Tetapi karena COVID teman-teman, maka Bu Ida, mahasiswa saya, itu mengkonvert menjadi virtual PD, menjadi online PD. Nah, beliau itu bekerja keras dengan menggunakan berbagai cara. Menggunakan Zoom, menggunakan Google Classroom, menggunakan Google Classroom, Zoom, WA. Nah, pada penelitian tahap pertama itu sangat challenging. Yang menarik adalah ketika saya katakan bagaimana kalau penelitian tahap kedua pada putaran yang kedua, bagaimana kalau kamu menggunakan Facebook? Ternyata ya, itu heran ya, kenapa susah dengan Google Classroom, susah dengan Zoom, tetapi gampang dengan Facebook. Nah, bagaimana cara dia meng-capture datanya? Dia meng-capture-nya secara manual. Jadi seluruh postingan copy paste, tapi ini kan dalam periode tertentu saja, yaitu 6 bulan. Oke. Karena dia belum mendapatkan analitik yang bisa dia gunakan.
Recording in progress.
Okay, next question, Ibu, from Pak Sukarna, ya. What are the simple ways of teachers for reducing the students' addiction to Facebook or online games? Ibu.
Saya kira yang utama itu mereka tahu sebenarnya konsekuensi dari apa yang dilakukannya. Sesungguhnya engage di dalam sosial media itu kan sama saja sebenarnya kita membuat histori ya, membuat sejarah diri kita, iya enggak? Kalau kita biasanya ngobrol dengan orang atau gosip dengan orang, itu kan tidak terekam ya, iya enggak? Tidak terekam, kita bisa saja ngomong apa saja. Tetapi itu terekam semua. Nah, karena ini sekarang, ini saya berikan saja contoh ya, bahwa tidak bisa dihindari, company itu menggunakan sosial media untuk meng-capture attitude seseorang atau history seseorang. Ya kan? Karena company atau para employer itu mau mencari calon pekerja yang baik, yang bisa mengontrol diri, yang bisa memanage waktu. Nah, itu perlu kita beritahu kepada anak-anak kita. Saya kira we have to keep communicating and give them some cases about the danger of using social media in appropriately.
Okay, I think we still have 1 minute. This is the last question, Ibu Mesuri. There is a relationship between Facebook and gender. Actually, I think you have explained this topic, but maybe you have another thing that you can told the Rega about the question. Okay.
Ya, jadi I have explained ya. Jadi memang berdasarkan literatur itu ada beda perilaku perempuan dan laki-laki di dalam berFacebook. Oke? Nah, Bu Maisuri itu meneliti khusus pada konteks guru. Bagaimana sih enggak? Kan teman-teman gampannya kalau misalnya training guru, perempuan itu kan sering kurang kesempatannya. Misalnya karena perjalanannya jauh, harus ngurus rumah tangga, harus ngurus suami, ngurus anak, akhirnya juga nggak punya kesempatan itu. Nah sekarang Bu Maisuri itu kan mencoba menggunakan Facebook untuk membelajarkan guru. Ternyata kalau sudah di Facebook, setelah saya lihat jumlah postingannya tidak begitu berbeda, tidak ada perbedaan signifikan. Oke, ada perbedaan signifikan dari dia suka komen atau like, tapi apa yang berbeda? Itu isinya. Contoh saja yang sangat mudah. Laki-laki ini kalau memposting lebih cenderung pada kasih soal-soal matematika. Oke? Nah, perempuannya itu dia cenderung ngomong kalau matematik itu bagaimana cara mengajarkannya. Misalnya laki-laki memberikan postingnya itu problem solving tentang pola bilangan. Nah, kalau perempuan ini lebih senang pada bagaimana mengajarkannya, siswa saya kesulitannya di sini. Nah, itu adalah suatu indikasi pada professional developer. Sebenarnya ini perlu cara yang bagaimana sedemikian sehingga kita tuh sama-sama membangun potensi laki-laki dan perempuan. Itu sebenarnya idenya ya. Sehingga saya meneliti tentang itu. Terima kasih banyak, ada banyak pertanyaan. I love all the questions.
Cuma waktunya terbatas.
Yeah.
Okay, thank you very much for the audience, for the active participation. And ladies and gentlemen, finally we come to the end of this section, section 3. Before that, I would like to ask for every invited speaker to give one sentence for final remark. I start from Professor Muhammad Salmi. Maybe you can give one sentence, maybe motivational sentence, just one sentence. Professor Salmi.
Keep up the excellent job, MIPA University Negeri Makassar.
Wow, thank you very much, Professor. And next from Professor Chen, maybe you have a motivational sentence, just one sentence for final remark.
Okay, thank you very much. after every my talk about this kind of conference, I just really hope I have the opportunity to go to Makassar again. Okay, thank you.
Same here, same here.
Yes.
And also, okay. And also, we hope Professor Moh Salmi also can come to our campus again. And
I would like that.
yes, the last is from Ibu Profesor Dr. Ibu Maisuri. Final remark, Bu, mungkin satu kalimat motivasi mungkin untuk kita semua ini.
Okay. It is okay, teman-teman. It is okay to use social media. Okay, but every time you use social media, can you stop for a while and ask yourself why I am using it? And can I use it to create impact to others people? So, in bahasa Indonesia, teman-teman oke lah pakai Facebook, oke gitu ya. Tetapi boleh nggak sesekali itu berhenti sejenak untuk mengatakan, apa yang saya kerjakan di Facebook ini? Apa yang saya lakukan? Untuk apa? Bisa nggak saya menggunakan ini untuk mendatangkan mendatangkan manfaat buat orang lain? Thank you.
Thank you very much, Bu. Yeah, thank you very much. And we would like to say thanks again to invited speaker, Profesor Moh Salmi. Terima kasih banyak, Prof. Syukran kasira, Profesor Chen Sheshe, Prof. And Dr. Ibu Maisuri. Terima kasih banyak, Bu, for the informative and interesting talk. And thank you for the audiences for the active participation. Hopefully the presentation will be beneficial for everybody. Thank you for your attention. And the screen I give back to the master of ceremony. Adik Citra.
Thank you, Pak Jafruddin, for very good job.
Hey, Prof. Thank you, Prof.
All right, thank you very much for the moderator and all our invited speakers. That was a very insightful session. And ladies and gentlemen, now I would like to invite the head of committee to give the token of appreciation for our distinguished speakers. For Dr. Aswi, the screen is yours.
Thank you very much. It is our honor to have Professor Salmi, Professor Michael Chen, and Dr. Siti Maisuri Patahudin as the speakers in our international conference today. I would like to officially give the certificate of appreciation to the first Professor Salmi. Professor Salmi, please kindly receive the certificate of appreciation.
Thank you very much indeed. Thank you very much indeed. Appreciate it.
Thank you. For the second is to Professor Chen. Professor Chen, please kindly give the certificate of appreciation.
Thank you. I appreciate. Thank you very much. Thank you.
Thank you. The third is to Dr. Siti Maisuri Patahudin. Dr. Siti Maisuri Patahudin, please kindly receive the certificate of appreciation.
Thank you very much, Ibu Aswi.
Okay, so I give back to the master of ceremony.
Thank you very much for the head of committee to deliver the token of appreciation. For all our distinguished speakers, again, we would like to thank you for all the shared knowledge during this session. It's such an honor for us to have all of you here. And ladies and gentlemen, now we will start the second parallel session. But before that, of course, we will have a very short photo session. So I would like to invite all of you to open your camera. So our committee here will take a screenshot of all of you at every page.
Recording stopped.
We will start. First page. Second page, third page, fourth, fifth, sixth, seventh, and the eighth page. All right, thank you very much. Thank you very much for all your participations. And now we will soon start the second parallel session. For all the presenter, please rename by using room code, paper number, and followed by your name. And for all the participants, you can rename your name. You put the affiliation and followed by your full name. Now you can join the breakout room.
For statistics or education.
Okay, the committee is preparing the breakout rooms. All right, for all the participants who want to join the breakout room, room A and B, it is for statistics topic, and for room C, it is for math and education topic. So you can join any room that you are interested. So again, I would like to inform you that the breakout room is already opened. So for all the participants, you can join any room that you are interested in. For room A and B, the topic will be about statistics. Meanwhile, room C, the topic will be about mathematics and also education.
Citra, saya di situ room C1 tapi yang tersedia room C2 ya, memang ya? Memang begitu ya, C2.
C1 itu kemarin deh ya Pak.
Halo.
Oh.
Halo Kak. Kemarin kayaknya kita Kak di tempatku Kak. Makanya saya cari. Tapi kayaknya bisa digabung Kak di C2 kayaknya Kak. Husnul.
Oh kemarin.
Iya, kemarin saya cari di mana Kak Jafar ini.
Iya. Kira hari ini salah lihat. Oh iya.
Oh iya.
Berarti saya gabung di C2 ya. Nanti enggak apa-apa terakhir aja kalau memang ini. Atau yang ada ini.
Mana Husnul? Halo?
Tumpuk berapa kontumnya?